any Halloween stuff on? You have orange. Is that orange or is it pink? Pink, I guess.
Yeah.
Salmon. We'll go with salmon.
Yeah.
There we go. Sorry, I'm a little slow today, apparently. These cords. Anyone have plans for the 4 days? Relax, not think about school for a couple of days, maybe till Monday at least. Sleep, yes. Sleep is a good plan too. My older daughter plays softball, and thankfully she has nothing this weekend. Next weekend, she has an 8 o'clock practice in Newcastle. Mr. Kane will be taking her. But you can get up and go. 8 o'clock's a little rough to drive to Newcastle. I have to leave around 7 on Saturday. Okie doke. So happy Friday. Happy 4-day weekend. Almost. I missed it. 5 hours. You guys will be on your way to a 4-day weekend. We're going to go over a couple of problems from the book, specifically 39, which is a really great problem. We'll talk about that. I'm going to talk about the other groups of problems. I might not necessarily work through them, but at least kind of talk about what the question was asking, how to approach the problem. We are going to do one more example in your notes today, and it is a problem where we're going to use successive synthetic division. So we'll talk about what that means. And then there's a review worksheet for today, and it's a review worksheet on dividing polynomials. So that'll be kind of hopefully good to get started in class. A little reminder, this is really important. Wednesday, and hopefully you've heard this like 15 times throughout the week, is not remote learning. Wednesday, everybody at home will be in here on Wednesday. Thursday is remote learning next week, and Friday, you guys will be here in the class. So I will see you in a week from today, which is kind of weird. But again, Wednesday Wednesday is in-person learning for cohort 1. Thursday is remote learning. Friday, you guys are in class. And I did send out an email with that information with the agenda for next week as well. So I know you guys get a lot of emails, but try and look for the emails that come directly from the teacher for sure. So we are going to talk about number 39. So if you want to find your homework and look at number 39. Is a fantastic problem because it asks you to, I think the directions wanted you to divide using synthetic division. I can't remember exactly what the directions said because I only clipped to this part of it. But it gives you a function and it gives you a value of k. And k is a radical, the square root of 2. So that k value, the square root of 2, I do want you to keep it as the square root of 2 and not convert it into a decimal form, but we're going to keep it in an exact form. Yes, you can divide with a radical. You can divide with a fraction. We could have a fraction in there as well. So that's my k value. That's going to go in the circle. So anytime they give you k, that's what goes into the circle, the actual value itself. And then the coefficients, we have a 1, 3, -2, -14. They are all there. They're in order. Every power is represented. Underneath the -14 is going to pop out my remainder. All right. So this synthetic division process. Hannah, what do you do first? You bring down the 1. All right. Drop that down. And then what do you do? Multiply 1 in the square root of 2. What is 1 times the square root of 2? Square root of 2. So you move diagonal, you place the square root of 2 underneath. And then, Hannah, what are you supposed to do? Yeah, you add. So when you add 3 with the square root of 2, are they like terms, like numbers? No. But I can write it as 3 plus the square root of 2. And that's how you're going to write it. So no, I don't want to know that that number is 4.41. But I want to know that it's 3 plus the square root of 2, the actual value, not a decimal rounded value. All right, so Hannah, if we continue, what would you do next?
Multiply 3 plus square root of 2 times 3.
Right, so whatever's in my circle needs to be multiplied by everything underneath our bar. This little L here equals bar. I'm going to do it on the side. We have the square root of 2. We're multiplying it by this entire quantity, 3 plus the square root of 2. All right, when you multiply, I have the square root of 2 times 3. How do you write that, the square root of 2 times 3? What does that become?
3 square root of 2.
Yeah, that just stays 3 square root of 2. The whole number is outside, separate from the radical, so it stays outside, and then the square root of 2 is underneath. So if you have a number outside, it doesn't affect the number underneath the radical or inside the radical. And then we have the square root of 2 times the square root of 2. Darby, what is the square root of 2 times the square root of 2? 2. That's just 2. So when I multiply those together, I end up with 3 square root of 2 plus 2. So I'm going to move diagonally, 3 square root of 2 plus 2. When you add those together, I'm looking at adding a -2 plus 3 square root of 2 plus 2. Kaden, what do you have when you add them together? Yeah, my 2's cancel because I have a positive and a negative. We just end up with 3 square root of 2. Kind of nice. Not so bad. And then, Kaden, what would you do next?
Multiply 3 square root of 2 by the square root of 2.
Yeah, so that number in my circle, that k value, again, I need to multiply it by the value underneath. So we're taking the square root of 2 times 3 square root of 2. Kaden, how do you actually multiply those?
It would just be 3 times 2.
Yeah, it's just 3 times 2. Again, the radicals are the like terms. They get multiplied together. The square root of 2 and the square root of 2 is the square root of 4. 2 times 2 makes 4. Well, the square root of 4 is just 2. So this is really 3 times 2, which is what, Kaden? 6. So when I come back up here, I get a 6 here, just a 6. And my remainder would be a -8. So it looks like it should be evil and messy and crazy. And if you converted that to a decimal, you're not going to get the exact -8. You're going to have probably a number that's a little less or a little more. Maybe -7 point something or -8 point something. But you don't need to convert it to a decimal. So when we write our answer, remember we started with x cubed. So Jenny, that means this 1 goes within x squared. So writing my answer, we divided with the square root of 2. I'm going to write it as a factor. So as a factor, that really means I have x minus the square root of 2. That's what you do when you're dividing. You're kind of pulling that value out. You're writing it as a factor in parentheses. And then I have an x squared because it was a 1. We have this 3 plus the square root of 2. Well, all of that goes with my x term. I'm just gonna group it together. 3 plus the square root of 2, all of that is times x. And then I have the end number that's by itself at 3 square roots of 2. And then finally my remainder is separate and it's gonna go last, minus 8. So I have what I divided with, our divisor. We have our quotient, the answer that we got. And over here is the remainder. Make sure I go far enough. Questions? Fantastic test question. Right? Wish you could see my face right now. I get so excited about this stuff and you can't see my expressions as well. Any questions? Maybe I had too much coffee already this morning. Maybe I need to tone it down a little bit. Any questions at home? So just talking about 2 other groups of problems. The next group of problems, I do think I tried to get the directions. Yeah, so this one says use the remainder theorem and synthetic division to evaluate the function at each given term. And then it's written a little differently. It's written as f of 1, f of negative 2, f of 1/2, f of 2. The number inside there, how does that number work with synthetic division? Where does it go with synthetic division, Barbie? Yeah, that's your k value. Yes, it's usually x, but the remainder theorem says f of k equals r. That's what the remainder theorem says. So you're going to take each one of those. You're going to have to do this 4 times. But you would use the 1 with the 2. Don't forget, there's no x squared here. That's the little trick in this problem. A 0, a negative 7, and then a 3. So I would do that 4 times. You'd then use a negative 2, you'd use the 1/2, you'd use the 2. Just getting you to kind of practice that pattern of the synthetic division, but then also realizing whatever you get for that remainder down here, that remainder becomes your y value. So you get a 1, and then comma, whatever that remainder would be. They're represented together. It's an ordered pair on your graph. So the number you're dividing with is k, or my x in my graph. The remainder is the y of the graph. It creates an ordered pair. Questions on that? That was a question that I saw on the sheet. The last group of questions says use synthetic division to show that x is a solution of the 3rd degree polynomial. Sometimes the wording of this, it's a little confusing, but our goal is to show that the x is a solution. And then it says use the result to factor the polynomial completely. So I have a polynomial for 47. My x value is 2. Again, what are you doing with that 2? Where does it go? Yeah, that's still my k value. So x is equal to k. So that's my k value. Again, with 47, I have x cubed, missing x squared. That's going to be the little trick that you're going to have to kind of look at. There is no x squared value. So I need to plug in a 0, then a negative 7, and a 6. How would you show that x is a solution with synthetic division?
You would solve it so the remainder is 0.
Yeah, so this remainder is 0. That means my x is a solution. It's a 0. It's an x-intercept. They all mean the same thing. That's how you show an x value is a solution with synthetic division. You get a 0 answer, you get a remainder of 0, you have a solution of 0. That value should be 0 if it's a solution. So if we work through this here, Jenny bringing down the 1, moving diagonal, you get
2.
and then you have
2.
moving diagonal,
4. Then you have negative 3. Negative 6.
and we get 0. So what's left here is x squared plus 2x minus 3. So I showed that it was a solution because I got a 0. So now I know that's a solution. And then it said use the result to factor the polynomial completely. Gianna, how would you factor the rest of this result here?
You would take out a positive
Nice job. And then we had x equals 2, which as a factor would become x minus 2. So again, I think sometimes the question, like what is it being phrased, what is it asking for, that might make it seem a little confusing. But synthetic division, remainder of 0 means it's a solution, an x-intercept, a factor, a 0, any of those terms. Questions? So we're going to do one more problem in your notes. So if you can take out your, or turn to find your chapter 2 notes. This is still section 3 with the synthetic division. And it is example 5. So still synthetic division that we were working on yesterday, same section. I'm not exactly sure what slide it is. What slide you have there. You have a page number. 26, thank you. Page 26, or slide 26. So this kind of is nice because it's asking us to do something that we were just talking about. We have a big function here of x to the 4th, so a 4th degree polynomial. It's called a quartic, that's a 4th degree polynomial. It wants us to show that x minus 2 and x plus 3 are factors. How do we know that they are factors? So Jeremy, how would I know that an x minus 2 or an x plus 3 is a factor of a polynomial? Excellent. So he said if you divide a polynomial by the 2 or by the negative 3, we should have a remainder of 0. All right, we're going to do this first with the 2 and then stop. Don't do anything else. Just divide the 2 because I want to show you what we're going to do with that result that you get to try and factor this completely, because part B says factor completely. So just like the problem we did, our goal is to get this to factor completely, the one that we just did from the homework. So 2 is my k. Make sure those powers are in order. And I just want you to divide only with the 2. And stop, because we're going to do something with that answer. So Brenna, if I multiply 2 and 2, we get adding them together. Okay, continue multiplying,
22,
adding them,
18,
multiply,
36,
add,
9,
multiply,
18,
remainder.
0.
Phew, if it wasn't a 0, you did something incorrectly because it is saying show that it is a factor. So if you didn't get a 0, your math was probably just a little incorrect, made a little mistake somewhere. So the polynomial that we have left, if we started with x to the 4th, what would be the power of this polynomial, Jeremy? If we started with x to the 4th, what's the power of what we do? X to the 3rd. And then this would be x squared. This is x, and then it would just be a plus 9. This polynomial, that is a cubic polynomial, is still not factorable. But I can use it in successive synthetic division. If you do something successively, what does that mean? Not successfully, but successively. Darby?
Isn't that the artificial word from yesterday?
Oh, that was synthetic. That's the artificial. I'm sorry, still begins with S. Huh? So successive synthetic division.
Doesn't successive mean like in order?
In order, like one after the other. So they gave us another factor. We are going to take these coefficients, and we're going to use the new coefficients with my second factor. So we're going to kind of do this successively, one after the other. But our goal is to get this to break down. So now that I broke it down once, this still is related to the original polynomial. I'm going to take those new numbers and my -3 and try and continue to break this polynomial down so that what we have left, we can try and factor. So the goal here is to get this to factor completely. We're going to do that by trying to break it down one after the other. So that's what successive synthetic division is. So starting with a larger power, doing one, using the new polynomial, and trying the next factor. So multiply, add. You should still get a remainder of 0 because both of them were factors, which means they're x-intercepts, which means they're solutions, which means they're zeros, which means my 0 should be the remainder. So Hannah, now that we've divided a second time, what is the remaining polynomial? What's that power?
2x squared plus 5x plus 3.
Excellent. Is that something that we could try and factor? Yes, because this is a trinomial. It's a quadratic. So now I can try and factor this completely because we use that successive synthetic division where we're literally breaking down the original problem. Every time you break it down, it loses a power. So if I use division twice, that means it lost 2 powers compared to what it originally was. So factoring this, 2 and 3 multiply to be 6, 2 and 3 add to be 5. So 2x squared, 2x, 3x, and 3. I would take a 2 out of the first pair and a 3 out of the second pair. So factoring it using AC grouping, multiply A times C. Find the two numbers that multiply to be 6 but combine to be a positive 5. Write them in our expanded form and then pull out what they have in common. And I didn't pull out an x there. So 2x plus 3 and x plus 1. So let me write this over here so it looks a little nicer. So my polynomial, I showed that x plus 2 was a factor, so I'm going to write that because I did division. I also showed that x minus, let me go back, x minus 2 is a factor and x plus 3 is a factor. So we showed that with synthetic division. Once they're factors, we've pulled it out of the original polynomial. We continued to factor the rest of the polynomial, its result, and we got 2x plus 3 and x plus 1. That's my whole polynomial now factored. The power of 4. Mr. Cummings, we just factored a polynomial that was a quartic. By hand without using a calculator. Oh, but we can. You're supposed to be amazed, Mr. Cummings.
I am, I'm telling you, it's not possible. That's not
Not
reasonable.
possible without a calculator, right?
Exactly.
Uh-huh.
You can only do it on calculator.
Yeah. Get out of here.
I am leaving. Bye. Happy Friday.
Happy Friday. The last part says, what are the 4 real zeros of the function? So, Kaden, what are the 4 real zeros of the function?
2, -3, -3 over 2, and -1.
Awesome. So, he told you it wasn't possible. You're now going to say it is without a calculator. Totally doable. Because now we can divide. Questions? Everything's up crazy. It's okay. Not as crazy as your social studies teacher, though. She's even more crazy than I am. She wanted to walk in the rain last night. Like, let's go for a walk. I'm like, it's raining. She's like, oh, it's not raining that much. I'm like, oh, okay. It was raining more by the time I got home. I was pretty wet. She didn't seem to mind. So if you look at Google Classroom, Google Classroom has an assignment with both long and synthetic division. And there are 10 problems to review the two types of division that we talked about. Some of them just ask you to divide. Other questions will say factor it completely. So it'll say first divide and then factor. So do both. I just realized that I don't have an answer key posted because I brought my stuff home to do that last night and I didn't. So I'll get that right now posted for you so you have that to look at. Did you find it in Google Classroom? Yes, I'm going to make sure I upload it. So you have, wow, you got like 15 minutes. That's pretty good. Hopefully there's enough space for you. But if you have questions about what the problem is asking for, let me know. I tried to be pretty specific with what I wanted you to do with the question. So factor completely means break it down all the way. If it just says to divide, just divide. Make sure you're writing your answer though in that like formalized notation. And I'll get an answer key posted. Anybody at home have questions? So as you're working, if you run into questions, just shout it out. Mrs. Kane, I have a question.